Now, when you're doing this prediction, when you're doing it, you better have peroxide reacting when you think about it. Otherwise, how do we determine its concentration if it doesn't react? Right? I mean, when you think about it, and then same with the potassium permanganate, something in here better react. Otherwise, why bother using this chemical? Like when you're done, right? So you should have permanganate as your strongest oxidizing agent, and your peroxide is your strongest reducing agent. I mean, it's even though that's logically those two should react. If you use this method, you come up with that anyways, right? That's what it leads you to. And now you see the 2-to-5 ratio that you will need eventually to do your stoichiometry. That's what we needed to see. So I filled up the burette. Now you can see, just quickly watch for a demo color. The peroxide's hard to see because it's so dark. So if you need one of those meniscus finders, you know, you can sort of hold behind to see the meniscus, use it. Now I just remember you clean this with permanganate before you use it, and then I don't have my tip filled, and now you can really see that it's not filled. So before I take a reading here, remember I need to run liquid through and get air bubbles out. So I'll just do that quickly, and then I'll take a reading initial. So I want to get near the air bubble there. Open and close, open and close, it's gone. Okay? Now, that's my waste container. So I have one later for waste. My initial reading here. So remember, don't call this volume. It is just it's called a reading, and you're reading from the top down to 2 decimal places. So my initial volume reading here is 13.49. Now, it's actually, I made this myself, so I don't even know if it's the right concentration. But this is my potassium permanganate, right? So in your reaction, just so you can see what I need to do for stoichiometry, I know the initial volume of this ion that's in the solution, right? And what's the coefficient of this? 2. It's 2, right? Plus, and then this is a 5. Right? And then there's everything else. Now, I know the initial volume of this, and what's the concentration of this solution?
There's 0.008.
0?
Yeah. 0.
Okay. See what data you have? This is sorry, this is the initial volume reading. It's not the volume, it's the reading. Right? In milliliters. How much of this am I using? That's an actual volume. This is the unknown. It's just stoichiometry, right? Now, I need a final volume reading here before I can actually do the stoic. So now that's ready to go. I'm going to now pipette some peroxide. Now, with the peroxide, remember, rinse the pipette too with some chemical that's going in here. So I'm just going to pull up the peroxide and rinse it. And then I've got a waste container here. So let's just rinse it like you did in the acid base unit, same process. And then now I'm ready to pipette. Okay. Now I want 10 milliliters. We're using the volumetric pipette this time, not the granulated one. Okay, after I let it drain, what do I do?
Tip.
Touch the tip. Okay, so touch the tip to the side. If any liquid comes out, fine. If it doesn't, leave it. If there's a little bit left there, don't touch it. Now the sulfuric acid goes in, that extra 3 milliliters to acidify, so I'm just going to measure it with a graduated cylinder. I don't have an hydrometer, so quickly I'll get it out. milliliters, dump that in. It's now acidified. Now I'm ready to titrate. Now, just so you can understand the change here, this is what's purple, right? This is iron. No, this has no color, as you can see. Now, plus everything else, and then the product over here is Mn2+, right? Plus a few other things. Agreed? This has no color. If you look in your ion color chart, it's not, this ion doesn't show up there. We color it. So this is what I meant by, and when I add this purple solution to this, you would think that a purple and a colorless solution would mix and be light purple already, but it doesn't. It's because when these two react, I make something colorless. And that will continue to happen until we run out of this. When I run out of this, there's this reaction. There's nothing to make the purple solution disappear. So then it stays purple. Okay? That's the color change. It's because I run out of chemical to react with the purple to make the purple ion disappear. So I'll just add a little bit, the purple, but then because I'm not even close to endpoint or equivalent point, of course it's not purple yet. Right? So you add, so you titrate, and I did make this myself, so I'm not sure I made the concentration correctly. Because I was doing it in the demo, and we didn't have any peroxide solution made up yet. So I don't know if I have the right concentration. Hopefully I'll actually reach it. So I'm not there yet. Getting closer. Getting closer because it's taking longer to disappear. And remember that you can rinse the sides of the flask down to get some of the purple solution drips down the side. It has to end up down here. You can't leave it on the side, otherwise it doesn't react. And you've already measured it out, so you have to allow it to react. Dark. Okay, that's my rough trial, my first trial. It should be lighter than this, right? This is because obviously just when I used up all the peroxide, it'll be light pink. Then if I add too much of this, it's now excess. So I don't want it dark. This is too dark. I want it light pink or purple, whatever you want to call it in terms of color. But it needs to be lighter than this. But then I take my final volume reading, which is 25.92. Do a quick calculation. Looks like I used, about 20, a little over 21 something milliliters. Is that right? Oh, sorry, 12. I used up about 13, almost 13 mils. 12 to 13. Next time, my next trial, I know that I can go for about 12 and then go a little bit more slowly, right? So, but with this data, you can do the stoichiometry. So nowhere in here do you see that I show anything with the sulfuric acid I added. I added 3 mils, right? Nowhere do I need to show that. It's not part of the stoichiometry. It does not affect stoichiometry. It doesn't affect the reaction because the sulfate ion is a spectator, the proton is a spectator. It's just there to provide the right conditions for the reaction. Okay. Any questions about how to do this titration? Now, for Tuesday, you need to list, well, you're doing multiple trials.